So, hey everybody, this is Mr. Bells coming at you. I'm going to try and give you right now, maybe 10-15 minutes or so, information that you really need to know how to be able to be successful and pass the quiz coming up over chapter number 2 for Geometry A. So, here's the material. These are the things that you need to be really good at. So the first thing, if I give you a conditional statement, you need to be able to write the converse, the inverse, the contrapositive, and how to be able to write it also as a biconditional statement. So again, I just give you some quick things. If I play the game, then I will win the game. So there's my conditional statement if I just write it like that. So the converse would say, and reverse, it would say, if I win the game, then I played the game. The inverse would say, if I don't play the game, then I won't win the game. And the contrapositive would say, if I don't win the game, then I didn't play the game. And biconditional would say, I play the game if and only if I win the game. So those are the different ways that you need to be able to write them and understand them. And then we'll talk about truths and faults and all that kind of stuff on there. So then I'm going to have a whole section of conjectures. So I'm going to ask you, I'm going to give you some conjectures. I'm going to make some statements. And you need to tell me this. Is it always true? Is it sometimes true? Is it always false? Whatever it is, there's a statement. So a 40-degree angle is acute. So if I put something like that and I ask you, well, is that always true, sometimes true, or is it always false? 40-degree angle is acute. That's always true. Okay. So so I'll give you a bunch of different statements. So it could be stuff with linear pairs, could be with right angles, could be anything that we've dealt with. So know all your geometry facts and whether or not my statements are true, sometimes true, always false, always true, whatever it is. Okay. So like for instance, if I had this and I put A and I put a B and I put a C and I said B is the midpoint of AC. Well, all I know right now is that B is between it. So in this case, I would have to say that sometimes it's true that B could be the midpoint of AC. Now, if I went like this and put those little segment markings on there, then I would say that that's always true. And if it was actually like this, and I got A here, and I got C here, and I said that B is the midpoint of AC, that would be always false, because it's not between them, so it can't exactly be a midpoint. Okay? So there's statements like that that we're going to look for. Know the difference between supplementary angles and complementary angles, and be able to draw pictures of them and understand the differences between them. So between supplementary and complementary angles. So like if I said two angles are complementary and one of them's obtuse. So if I made that statement, I have two angles that are complementary and one of them is obtuse. And say, is that possible, yes or no? You would have to say, no, that's not possible. Because an obtuse angle is greater than 90 degrees and less than 180. And complementary by definition means it has to be two angles that add up to 90 degrees. So you can't have one that's bigger than 90 degrees, because in our course you can't have any negative angles. Okay? So then there's stuff on inductive and deductive reasoning. So you need to make sure that you understand what we've talked about inductive and deductive reasoning. Inductive, again, is based on observations or patterns established that makes you think that you know which way it's going to go next, and deductive is based on facts. So observations, OBS, facts. If I said theorems, postulates, properties, and definitions, those are all facts. Those are things that are deductive-based proofs. Okay, so I'm going to have some things like this. I'm going to say, hey, I'm going to give you a statement, and I'm going to ask you, is that a true statement? Okay, so maybe I'm going to make up some sort of postulate, and I'm going to say, hey, is this an actual postulate? Is this true, or is this false? So like maybe I say something like this. I say that all right angles are congruent. Is that a true or a false statement? And you would say, yeah, that is true. We could justify that by the right angle congruence theorem. But I'm going to have a bunch of them. So just know them all, as many of them as you can. That will help you. Good deal. These two angles right here. These two angles. Are these two angles adjacent to each other? And the answer is no, they're not adjacent. And if I said these two angles, we'll call it angle A and angle B. Is it possible that these two angles are supplementary? The answer is yes, it is possible. Is it a guarantee? Nope, it's not a guarantee. However, if I put this as 130 degrees, and I said that these are supplementary, how big is angle A? Then you would have to come over here and you would go, hey, angle A must be 50 degrees, because we know that supplementary means that the two angles add up to 180 degrees. And now I say, are these two a linear pair? Your answer would actually be no, because if they were a linear pair, they would need to be adjacent, and they don't share any points. One of them's over here, and one of them's over here. Okay, so we got a whole section on that. We have a section on law of detachment, and the law of syllogism. So make sure you've reviewed those two things and how they work out and how we can use them to apply logical statements. I'm going to give you some algebra related problems. So maybe I'm going to give you something like this. I'll give you this 3x plus 2 and this one 4x. Let's go minus 16, and this is angle B. And I want to know, what is the measure of angle B? And you would have to be able to go, oh, well, look, these are vertical angles. We know that vertical angles are congruent. And you could write that 3x plus 2 equals 4x minus 16. Then solve this, and you get x equals 18. And then if x equals 18, you can plug that back up into there. 3 times 18 is 54, plus 2 is 56 degrees. And if that's 56 degrees, and this angle and this angle are supplementary, then we know that angle B must be 124 degrees. Okay, so that's using some of those properties. So you're going to have to use some algebra with some general understanding of some things, and go from there. Okay. I might give you a picture of some stuff and ask you to tell me what you can or cannot determine from that picture. Like if I said right now, I give you this picture right here, and I said, here's A, here's B, and here's C. And I said, hey, angle ABC is a right angle. Yes or no? Is that true? And the answer at this point is no. I don't know that it's true. Okay. If I said that angle ABC is supplementary to a 90-degree angle, then would it be true? Well, yes, then it would have to be true. If I said that ray AB and ray BC are perpendicular to each other, then yes, I could say that that's true. If I put a little box in here, that defines that to be perpendicular, which means it's got to be a right angle. All of those things are true. If I was to draw a angle in there to make triangles, and I put this as 45 degrees and this is 45 degrees, then yes, that would have to be a right angle. So knowing whether or not we can or cannot assume things to be true based on a picture, and again, your list of theorems, properties, postulates, definitions, all those things, I would have them. In fact, if you have them, that list written out, not your textbook, right? You can't use your textbook. But if you have it written out and you put pictures with it and stuff like that, just a whole section of these things, I'll let you use them. You can use quiz/test. Okay, but you got to be able to do that. So that's pretty much most of the things that are on this test. You know, when I said this algebra stuff, that might occur 2 or 3 times during the problem, so you just have to be able to make sure that you write the right equations and solve the right equations for it. There might be some justify some things, but there's not any big, long, formal 2-column proofs that we've worked on. Just too hard for us to be able to do in the format that we have right now. Once we get in person, we'll be able to do a little bit more stuff with this, where I can work with you a little bit more, and hopefully we'll get some good things out of that. So, this is Mr. Bells. Hope this is helpful to you. Please, again, make sure you've watched your videos, that you're on top of that stuff. Make sure that you've done all the online homework on Big It Is Math, and let's see if we can make this quiz/test much better than the last one that we had in class. We'll talk to you later. Thanks.